All right. Hello, everyone. Welcome to an introduction to programming in Python. If you're here for that, you're in the right spot. And if not, uh, you're not in the right spot. My name is Ellen Duong. I am a lead research software engineer here at the Center for Computation and Visualization. And that is part of OIT. And I help out researchers kind of develop software tools that they may need for any sort of grant or like paper or whatever their research is. So like an example project is that I work with the public health department on creating dashboards that visualize communities that are most at risk for overdose deaths. And then organizations kind of take that data to kind of think about where they may want to send resources to or set up clinics or kind of other things like that. In past life, well, not past life, my same life, but previously I got a I did a I did my undergrad and grad at Penn. I studied digital media design and computer graphics and game technologies. And what that means is that I did computer science and fine arts. That's basically what I did. And since then, I've taught different workshops. I've taught introduction to Python for Columbia, and I did some internships at places, and now I'm here. So, and I love like kind of seeing how students kind of react to certain things and kind of get information kind of and how they kind of figure out how to solve certain problems, because as a teacher myself, and someone who has like kind of known about all of this, I kind of have certain ways that I solve problems. And then I learn a lot from my own students about, oh, that's a different way that I never really thought of learning. Um, so I guess before we kind of get started, I kind of want to get a sense of the room. So how many of you have no coding experience? Okay. How many of you would consider yourself a beginner? A beginner. Okay, we have a lot more hands for that. Beginner may have seen it. How many of you feel comfortable starting a project in coding? Yeah, okay. Great. How many of you have not done Python before? Okay, so Python might be a new language to about half of you. Um, yeah. So it looks like there's some coding experience among the group. Um, and that's kind of why we're here to kind of learn a little bit about Python. Um, but yeah, oh man, this is like covering. Hold on. So to kind of ground us, I always think about like, why learn computer science? Why is everyone kind of getting into like programming and stuff like that? Well, it's kind of everywhere. It's like the internet, social media consumption, everything. Like everything that I touch these days is like, oh, someone had to code this. Someone had to make this automation. Someone had to do this. And in a lot of ways, like a lot of that's like, entertainment and things like that. But then there's also like other ways that it is used, such as like translation services. I recently just came back from Japan and I used my phone like entirely to communicate with people. And that was absolutely amazing. I even used my like Google Lens to like take pictures of like Japanese signs and get it to translate for me. That was like critical in like figuring out like the temperature stats on the wall, because I was like, how do I turn this up or down? So those are kind of like crucial things that like are just kind of a part of my life now. But yeah, there's it's used a lot in like robotics, AI, machine learning, computer vision, all of these things that are kind of popping up these days. And I think a lot of people have dabbled in some sort of AI a little bit with like ChatGPT, Copilot, kind of things like that. Even Google, when you search on Google, like Gemini's kind of there, like answering your questions and kind of things like that. So why Python? Why are we here for Python? What are some of the reasons why you're here to learn about Python? Anyone? Yeah?
For my image processing.
Image processing. Great, cool. Anyone else? Yes. It's widely used in the industry. Yes, it is. One more? Yes. Machine learning and AI stuff. Great. So, I mean, for all those reasons, like, that's why people kind of gravitate towards Python. The quote here from the Python official website is, Python is powerful and fast, plays well with others, runs everywhere, is friendly, easy to learn, and is open. That is the quote from there. As you may or may not know, Python is an interpreted scripting language. What that kind of means is that, what that basically means is that we're going to be evaluating each line by line as we go through, and you'll see that. It's a high-level programming language, which means that like you don't really have to deal with like flipping bits or anything, or like memory or kind of things like that. Like a lot of stuff that was like low level has been a little bit more abstracted and it is a little bit more readable. That's kind of how I think about it when I'm like, oh, it's a high level programming language. It's a little bit more readable than it would be. Um, it can be object oriented. And when I think about object oriented, I think about Pokemon. Okay, stay with me. So a Pokemon is a Pokemon, but we're going to call it an object. I know I'm objectifying Pokemon, but one second. So Pikachu has these abilities and stats. So Pikachu has like some sort of defense stat, some attack stat, and things like that. And then it also has actions. It has like Thunderbolt or like Tackle. So those are kind of like what I think about like object oriented. It's like this object that has attributes and it has methods or attacks, kind of things like that. So that's what I think about when I think about object oriented. It's dynamically typed. So if you have any experience with other programming languages, Python is one where Python will kind of be like, I think that's a number. That's an int. That's totally a float. Whereas in other languages, like I think like Java, you have to explicitly say like, this is an integer. Python's garbage collected, which means we don't have to care about memory. Well, if you're dealing with like big data, you might have to think about memory, but for our intents and purposes, we can like be like, it's fine. But it's garbage collected, meaning you don't have to like allocate or deallocate things from memory. If you are familiar with low-level programming languages like C or C++, like you might have to do that. So why Python? You hit on some of the things. It's easy to learn. It's a very readable language, and that has to do with the styling standards of Python as well. We'll talk about that in a bit. There's hundreds of libraries and frameworks. It's very well supported by the community. Like it has a huge user base and community. I call it the second best language for everything because Python is a pretty like general language for stuff, but there's like maybe a better language for the specific thing you need, right? So like JavaScript maybe would be better for web development, but I guess you could do web development in Python, or you could do like MATLAB has its like scope of kind of like who this would be for, or R for statisticians, or Julia, things like that. But the concepts that you learn here in Python are very transferable to things in other languages as well. So as you can see here, like data science and analytics. I know a bunch of you are here from the data science master's program, so welcome. As with all programming languages, automation, oh my gosh, getting a robot to do my things for me. Yes. Yeah, and it's open source, which means that like you could contribute to it. If you see something that's like, hey, this is weird, why does it work this way? Like, you can submit a ticket. Someone might actually get back to you. Or you could fix it. Things like that. All right. So that's an introduction to kind of like what Python is. Now we're going to get through our environment setup. So if you want to join along, take out your computers. But if you don't, that's totally okay. If you already have your, oh, I guess I have this for Google Colab now. Oh, great. So if you already have like a development environment that you have set up Python in, you can use that. But today I'm going to use Google Colab. So what that means, I'm just going to go to my Google Drive. I'm going to say new, and then I'm going to click more, and I'm going to click Google Collaboratory. Great. Okay, so what this does is that it opened up this notebook. Great. Cool. And we don't have to have any sort of setup. Like you don't need to install Python on your computer. If you already did install Python on your computer, feel free to do that. But if you just want to get started, Python's already loaded on here. It's in your browser. It's all great. Cool. There's two kinds of blocks we'll have here. There's going to be a text block where you can say, hello, this is rich text. So you can kind of do that. And if you press like, I think shift return, I think it will do that. If I press like a code thing here, if I say like print, let me just see if this works. Whoa, this is taking a long time. Okay, great. So, oh, I should make this bigger because this is tiny. So there's two kind of boxes. I'm pretty much going to use the coding blocks, but feel free to do whatever you want. There's like trash cans here and things like that. I think, nope, that's a code snippet. Oh, okay. We don't have access to the terminal because I don't have Pro, but that's okay. I don't need the terminal. Great. Okay. Did everyone open up a collab? Are we good? Are we ready? Great. Cool. So let's get started. The first thing that I just did, and you just saw me do, was I did this print statement, which basically is the first thing that anyone pretty much does whenever they set up their environment, just to see if their environment is set up correctly. So here I basically typed in print, and then in these parentheses, I put in a parameter, an argument into this print function. And then I said, I'm going to put it in quotation marks, hello world. So in my collab over here, I put in those same things in, and I ran that, I pressed the play, and it says, hello world. So it looks like my environment's been set up correctly. So go ahead and do that. Something before we kind of get into further programming is the kind of thing about the program design cycle when we're kind of thinking about all this stuff. So something that kind of happens is like in my work, like I define some sort of task. I kind of think about what I need in that task. I then design a little bit about how am I going to do about this? And then I start coding. As you notice, there's 3 steps before coding. The biggest mistake I've seen students do is, oh, I got the task, I'm going to go code right now. And I'm like, hold on. You could save a lot of headache if you just stepped back and thought about it before you jumped into coding. Program design is a huge thing before you even get to it. And then after coding, there's documenting, there's testing, there's maintenance, and then you just kind of keep going. In reality, it looks more like this. If some of you have coded before, you might be familiar with this. I oftentimes bump back and forth between coding and testing and things like that. And then something comes up. Oh, it's a good time. Another thing to note is that you can comment your code. So in Python, you can use the hashtag or the pound symbol or the tic-tac-toe board, however we call it these days. And if you put that in, Python knows that this is a comment. So if I go here, I'm going to edit the same code block actually. If I put here, comment, and I pressed play, I get an error saying, hey, name comment is not defined. And it's like, I didn't, because it kind of interprets it as something that needs to be run. But if I put the pound symbol behind there and I press play, it runs as expected. So anything here is not run. You can also do inline comments, so feel free to do that as well. And that's kind of how we'll get started. Okay, let's kind of get into some basics. So today, the goal of today's workshop is that we are going to create a text-based guess the number game. So that's what we're going to work on today. So how that's going to work is that if you've played guess the number, it's essentially like a 2-player game. So in this case, the computer is going to be a player, I guess. So there's a secret number, okay, that we're going to have, and the user is going to have 3 chances to guess what that secret number is. The computer is going to give us back some feedback about, hey, you might want to guess higher or you might want to guess lower, okay? And then we're going to guess again until we get the correct answer. So that's what our goal is today by the end of this workshop. And so before we get there, we need to learn some basics. So some basic data types. In Python, we have, these are some of the basic data types. We have integers, which are integers. We have floats, which are basically numbers that can have decimals, and they can have kind of different variations of that. So some examples of that are like 3.14, 0.1, 7.8. Those are an example of that. We have strings, and we actually had a string earlier, and one of those was hello world. So that's a string. Also, if you put a number inside of quotation marks, it's also going to be a string. So it's 12, but it's 12 as a string, not 12 a number. So you might have to think about that sometimes. Booleans, that is a discrete value, which is either true or false. So that's how we're going to be thinking about that. And those will be useful a little bit later. And one we're probably not going to get to today is the null type. And this basically means there's nothing there. This is particularly present in real data. You might have missing data if you try to import your data and you're like, oh, I'm missing a whole bunch of fields. Why is that? So there's like a whole part of it of like needing to deal with cleaning data or interpreting what does missing data mean? Can you make that 0 or things like that? Those are some considerations you might have to think about. But we're not going to get that today. So we have some data types, and we can kind of like do that here right now. We can have like, oh, like we can do like 14 and it knows about it, or we can do like hello world and knows about it. But like we kind of need to save that data into a variable. A variable is a name for some sort of data that is assigned to. A variable has a data type. Python is a loosely weakly typed programming language, so Python will figure it out. You don't need to figure it out. Some rules about variable names is that you can't have spaces in your variable names. They have to start with either a letter or an underscore. They can't start with a number. You're only allowed alphanumerical and on an underscore. It's case sensitive and spelling sensitive. So for example, if you had name all lowercase, name capital, or name all caps, those are 3 different variables. And we have some reserved words that can't be used as a variable name, such as import. Import will be useful later on if you wanted to import a library. So in Python, we have a whole bunch of community libraries that people import in to use certain like functions and things. For Python, the naming convention is snake case. So snake case is this all lowercase and underscores as spaces. And then we have screaming snake case, which is for constants or globals. So these are things that like don't change. But for our intents and purposes today, we're going to use snake case. You can take a look a little bit more about the Python style guide here. If you wanted to kind of figure out a little bit more about style, but I think those are kind of a good basis for that. So I'm actually going to open up yeah, okay, great. So now we have to think about, I have this thing, hello world. Now I want to save that to a variable. So, or actually, yeah. So actually I'll do something like name. Name equals Ellis. So this is my name. Welcome. So name is my variable. I could have chosen anything, like literally anything, right? And it would save it as that. And then if oh, I don't want to do that again. Hold on, let me take this out. And if I wanted to print name, it would know that that was what it was. If I tried to print a variable that didn't exist yet, I get this error saying, hey, it's not defined. So I made my name. That's great. You can also, make numbers like x equals 4. Notice that in Python, we have the variable name, we have the assignment operator, we have this, and then there's no semicolon. Python does not have any semicolons. Once we kind of get into a little bit more control flow, we'll have to think about indentation, but this is kind of good for right now. Python can do some arithmetic for us. It can do simple things like addition, subtraction, multiplication, division, even floor division. So I can do things like 4 plus 5, it'll say 9. Do 4 minus 5. Can do divided by 5. It does order of operations. Whatever that is. Does floor division. It does a whole bunch of stuff. Even does like exponents and mod. So you can do like 15 mod 2. It's 1. So that's the remainder after dividing, after all the division stuff. Can do things like that. So those are some things that we can kind of think about. Great. So I'm going to start a new notebook, and I'm going to make this notebook the guess the number one. Guess the number. So far, we've kind of learned about variables and variable assignment. So I think we can kind of get started with guess the number. Does anyone have an idea of like how we might want to use variables and variable assignment in guess the number? No? We have to pick a secret number. So that's what I'm going to do. So I'm going to say, let's say our secret number, and we're going to set that equal to, I don't know, 12. That's what I'm feeling like. It's not so secret, I guess. But I think that's okay. That's kind of the first things that we need to do. All right, so let's learn another concept that we're going to need. We're going to get an input from the user, because that's kind of the next step in our game. Because we need to think about, okay, we're going to set a number, right? Set a secret number. We're going to, ask the user for a guess. We're going to give the user feedback, right? And the user is going to guess again if they got it wrong. Something like that. I don't know. It's kind of the basis of it. So yeah, kind of next part is like input from the user. So how you get data is going to be varied differently. So sometimes you'll get data from like an Excel spreadsheet, a CSV file, a comma separated file. You can get data from a database. You might have to query like the cloud to get some data or things like that. In this case, we're going to get data back from our user. So there's this function called input, and this actually pauses the program and prompts the user to type something and then enter. So if we go back to, this is the one that I'm just using as scrap. If I say like input, what's your name? Okay. If I press play, it says, it prints out what's your name. And then I'm like, my name is Ellen. And it says Ellen. Great. But let's do something with that, right? So I want to save that output into a variable. So let me save that into name. And then what I can do is maybe I want to like, okay, so now if I run this, like, what's your name? And I'm like, my name's Ellen. It doesn't print out Ellen anymore. That's because we saved it to a variable. And it only really printed it out because we're in a notebook. Anyway, so now we can do something like our print that we had before. You could say like, hello, and then we oh, I didn't teach you this yet. I'm so sorry. Well, I basically want to do something like hello name. I kind of want to use that variable into here. I think it's going to be the next slide, but we're here. So if I do this right now, it's like I'm gonna put in Ellen, and it's like, oh, it says it doesn't use the variable name. So something we can do is in Python, there's this thing called F strings, which means formatted strings. And so what I can do is I can put an F before the quotation mark. And then inside of the quotation marks, I can put in these curly braces around the variable or any Python expression here that would evaluate to a string here. So if I do that, and I say Ellen, it says hello, Ellen. That's kind of nice. That way we didn't have to be like hard coding everyone's name to say hello. Now we can reuse the same bit of code and just ask everyone what's their name. What's your name? What's your name? Great. I think in Python is this concept of dry. Don't repeat yourself. That's what it means. And basically, if you've written it once, you should not have to write it twice. So that's kind of a thinking about like how much code can you reuse? Because you've already written it, you've already done the work. And plus, if you use it in many places, if you've copied and pasted all, you have to like update them all. But if you reference it, you can just use it. Great. So now, oh, I had some examples here. Great. So that's kind of nice. However, this is like when we got a string, right? If we get a number, so let's ask the user for a number. Input, number from 1 to 10, 1 to 100. Okay, if we do that, oh wait, hold on. I'll make this nicer. Hold on. I'm going to type num. Okay, so now I'm asking the user for a number. I'm gonna just say 50. All right. And this next thing I said type, and then I put in that variable. It says the 50 that I got is a string. If I do like type and just put in 50, it says it's an int. When we get something from the user, Python doesn't really know what it is, so it just considers everything a string. Okay. So when you import your data from like an Excel sheet or something like that, you might have to go in and be like, oh, this is like a number, this is this. But there's like data science specific packages like pandas or Plotly or like matplotlib or something like that. And in those libraries, if you import data, like they'll be like, oh, I kind of know that this is a number field. This is kind of this. But if you're just getting like just base Python, like it might interpret it as a string. Now, the problem with interpreting it as a string is that if I try to do some sort of like arithmetic with it, it's doing this, which is weird. It's because it's concatenating it. This is like a relic from like C. So Python's kind of built after C or whatever. So what this means is that for like a string, to just times a string by 2 means I'm just repeating the string again. So if I did like hello times 2, like it would just say hello, hello. That's what's happening here. So basically I'm like, this is not what I wanted. So what we're going to have to do is we're going to have to cast it. So casting means we're going to be changing it from one data type to another. So if I, oh, sorry. So casting it, I'm we're going to be great citizens here. So today, we're not going to do any error handling. We're just going to pretend. No, sorry, we are just going to be good citizens and not cause errors. We're just going to use the program as it was intended and not safeguard it. That is too much to do in an hour. But anyway, so int, and then we put in num, and then we can save that back to num. And then we just take type of num again. So type. Sorry, hold on. Print. Hold, please. Great. So I printed out the type of num before we casted it, and then it did this. Great. So now we have an integer. Great. So now that's something. So now we can get a user to ask the user for a guess. So let's save that as guess equals input. Guess a number from 1 to 100. Great. And we're just gonna print yes right now. Okay. Oh, you know what? I'm gonna make it a little nicer. Oh, oof. Great. So that's where we're at right now. Okay, we have a little bit more things to learn, and we'll make it. We're gonna make it. So remember earlier I talked about Booleans. They were true or false values. Now, that kind of gets interesting when you kind of think about relational operators. So relational operators are things like equal to. So like you can say like, is A equal to B? Is A not equal to B? Greater than, less than, greater than or equal to, less than or equal to. So things like, is 5 greater than 4? Oh my goodness. Oh, why is it doing this? Okay, well, it would say true, and then it would say false here. Why that's taking forever, I don't know. So basically it just says like true or false, things like that. Okay. Yeah, I guess we'll go through that. Why is this taking forever? Let's delete that. Delete all of this. Anyway, okay. So that's like what relational operators are. Wow. It's gonna do this. Oh, there it is. Great. Cool. True. In conjunction with that, we need to think about some logical relational operators. And to kind of think about that, we have to look at some truth tables. So in Python, you can connect some of those relational operator things with some logical operators. And we're going to talk about and we're going to talk about or. So and are things like, so there's this PQ table. So P over here is a variable. 0 means false, 1 means true. Q is also going to be like that as well. So zeros are false and ones are true. The and truth table basically states only when P and Q are true, will it be true? In all other instances, it's false. So if I do something like true and true, Python will say true. If I say true and false, it's like false, things like that. Or is a little bit different. Or basically says, so P or Q. Basically, it's saying P, if P is true or Q is true, then it's true. So that kind of makes sense. Oh, neither P or Q are true, so P or Q is false. And then one of P, one of Q is true. So that kind of makes sense that that's true. In this last case, both P and Q are true. P or Q is also true. So this is how or works. I think in English, we kind of think about exclusive or. It's either like this or that. But in the computer world, that's not how it works. So that is kind of the thinkings behind what we're going to need now to kind of think about our control, how we control the flow of our program. And how we do that is we use if statements. If statements are conditionals, and they are things that run, that conditionals are expressions that evaluate to either true or false, and then they're followed by an action. So for example, if it rains, then we'll watch a movie. If it's sunny, then we'll go outside. Right? So, I mean, yeah, if it's sunny, I mean, I'll go for a walk. If it's raining, there's no way you can get me out of my house. There's no way. So how that kind of works is we hit some sort of condition, evaluate that condition. If that's true, we do something. If that's false, we'll do something else, and then we'll continue with our program. It's kind of how it works. In Python, these are called if statements, and this is how it works. So we say if we have some sort of conditional statement, we have this colon here, and then these actions are indented in. And these conditional statements must evaluate to true or false. And if the statement is true, the action will execute. And if not, like any code that's indented won't be included. So if we say if, 5 is greater than 4, colon, don't forget the colon, press enter, you look and see it automatically indented. Print hello. Great. Now if I undented it, dedented, right, and print end, it'll print that. If I say if 5 is less than 4, it only prints end. You have to be careful because sometimes I've seen a lot of students do this where they meant to they're like, why isn't my thing printing? This is the start of Python not telling you about all your errors, because not all of your errors are syntax errors. Sometimes it's valid syntax, but logically it doesn't actually make sense. This is the start of that. Okay. So in addition to if statements, we also have else statements. We have things like if this condition is true, then we'll do this action. Otherwise, else, which is dedented, we'll do some other action. That's kind of how that works here. So that's kind of how this is going to work. So if we'll just say that, and we can say else, and then we could say print goodbye. Things like that. So this was false. So it went to the else and says goodbye. Great. You can also do else if statements, and that's basically saying like if this action else, and if that's false, it goes to the next condition. Elif is just the shorthand for else if, and it does that, and it does the action, and then otherwise it goes to the default action here. We don't need nested if statements here, but that can kind of get wild. If you have an if statement on the outer side, and then you could put one inside, this would only run if both conditions 1 and condition 2 are true. So it gets a little tricky. You start thinking about like, oh, wait a minute. My conditions are now nested. The more nested your program is, the more difficult it is to read. So kind of think about that when you're the more branches in your code that you have to deal with, the more you have to kind of make sure you're dealing with correctly. Great. So that's when I say guess the number. Great. So right now we kind of have everything we need to kind of make a preliminary guess the number game. We're going to do this without loops right now. I'm going to do it kind of quickly just because of time. So I'm going to cast this guess into an int. So I'm just going to do that right here. Great. I'm going to give the user some feedback. So I'm going to say things like, we're going to use an if statement here. And we're going to say like, if their guess, was greater than the secret number, I'm going to say like, oh, sorry. I'm going to say like, higher. No, sorry. I'm going to say like, if the guess was greater than the secret number, I'm going to tell them to guess lower. Else, if, the guess was less than the secret number, then I'm going to tell them so that they need to guess higher. And otherwise, I don't need to say if guess is equal to guess secret number because we've locked out all the other options. So print win. Great. So if we say 50, it's like, oh no, they should have guessed lower. If I said 12, they're like, oh, you win. If I guessed 5, it says higher. So now this is like one guess, but now we need to think about multiple guesses. Like, oh, if the user, guesses again, like I need them to guess again. So now, okay, so if they guess lower, they need to guess again. So I have to do things like, oh, okay, so they need to guess again. Okay. And then I need to give them feedback again. So hold on. Right? So I'm like, okay, so they need to guess again. So I'm saving guess again. I'm saying input. And I'm like, guess a number from 1 to 100. I'm like, okay, great. And then I have to do this again. Right? And I have to be like, okay, so if they did that, so now this is their second guess. But then they need to do that again if, they didn't do it. So now I'm like, oh, okay. So I'm like doing this. But as you can kind of see, like this is getting messy. Right? Like I'm getting lost. Like this indentation's not really working. I'm kind of like, like, oh, this needs to go here. Ooh, right. It's getting bad. It's getting pretty bad, isn't it? I actually also got lost. I actually don't know what happened. But if I run this, let me see what happens. If I run this, it's like, guess the number 50 lower. It kind of works. It kind of works. It kind of works. But this is terrible, okay? I don't get it. What is even happening? There's so many if statements. I'm losing my mind. Well, you could make that work. but it's kind of fragile. It's kind of hard. We're not going to do a while loop. We're just going to skip to for loops. There's two kinds of loops. There's for loops and there's while loops. Look up while loops later. A for loop is now we get to reuse code we've already written. Okay. So a for loop is basically you kind of take some sort of sequence and you kind of run through code and you loop through it and you keep doing that. So this is kind of the syntax. We have this keyword for, we have a variable, and that variable is in some sort of sequence, and we do some things here. So in our, here we have for, let's say I in, wow, it's been a while. For I could have just changed I to anything. I in range 3, oops, colon, print I. So this prints out 1, 0, 1, and 2. Great. This feels like what we want. We want the user to guess like 3 times. Whoa, this feels pretty good. But something we also want to think about is like, so that range function I just did, I did range 3. It started at 0. Python starts at 0. Other programming languages might start at 1. You gotta think about that. And kind of things like that. We don't have to get through that. The other thing, we have some loop controls. If you wanted to end something early, you can use keywords like break. That will break out of the loop. If you wanted to continue, you can just put this word continue. If you wanted to skip the rest of the loop. So in our guess the number game, I'm going to clean this up because this is crazy. Oh my Lord. Let's get rid of this. Let's print higher. Okay, so this is like back to when we had like one guess, right? Not bad. So now let's do like a for loop. So for I in range 3, colon, and I'm going to indent everything in. We'll do that same thing, you know? Well, so that's all I did. 50. Oh, see, I forgot to move this guess into the for loop. So now we have to ask the user for the guess inside the for loop. Notice that I'm testing a lot. I'm pressing run a lot because I want to see if this works. Okay, great. Okay, great. Cool. That seems like it worked, but what if I guessed 12 in the beginning? It says win and it's still asking me. So I want to actually exit out of the loop. So if I did break and I redid this, ooh, and I said 12, win. That's pretty good. If I lost the entire time, then I guess that's fine. You can have an ending message if you wanted to. But that's kind of what I have time here for today. That was a little bit of a whirlwind towards the end. I apologize. More things in Python. You get into, we did some basic data types. You can get into more other data types, things such as lists. Things, and lists are just kind of like, you know, like your grocery list. Or you can get into things that are like lists of lists, which a 2D list is basically like a matrix. Something like that. You can get into different libraries. So if you're in data science, like using like pandas or things like that. And then you get into things like data frames. Data frames really replicate things that you see in like Excel and things like that. So you might want to look into that. Questions here, or like, do people have questions of like what they kind of want to use it for and how could they get there? Yeah.
for the range, even though Python starts at 0, it goes 0, 1, 2. That's when it stops.
Yeah, so I had a slide on that. I'm sorry. I like did that. So basically, if you ever seen like in like math, you have like the hard bracket, like the square bracket is like you start here and then it ends on the soft bracket where it's like it doesn't include 3. So it's like hard bracket 0, comma 3 soft bracket. That's kind of how to think about it. And then you can also specify like a different parameters like start and stop and step here. Other questions? Yeah. I can definitely send off the slides. I don't know how to send it to you. I don't have a list of everyone that signed up. I could just send it. Yeah, email me if you want it. Here's my email. Yeah. Here's my email. For those of you on Zoom, here's the presentation. I've done other workshops where this is like the very beginning one, but in another workshop we could do Wordle. We could make Wordle. There's other workshops I think people will. There's like more data focused ones, but this one's just kind of the intro. I like keeping it fun. I feel like games are fun. Great. Well, thank you so much for everyone being here today. Thanks for spending the time with me. Thank you. Yeah, and if you want to send me an email, ask other questions, that's totally fine. So, no worries. Did we eat all the pizza? Great. Thank you, everyone on Zoom. Bye.
Thank you. Bye.